Hello, my name is Graham Wills. I am the Chief Architect for a new IBM visualization capability, and this is a short segment talking about the evolution of visualization for large data. A decade or so ago, big data meant long tables. When someone came to a visualization expert and said, "Does your engine handle big data?" a typical answer would be in terms of how many rows it could handle, how many points could be shown in a scatter plot, or so on. The situation now is very different. Showing 1,000,000 points in a scatter plot is possible, though not very useful, but a million is no longer a big data set. In terms of size alone, big means billions or trillions of data points. More commonly, big data also implies non-tabular data. Textual data, remote sensing data, simulation data, geotemporal data, all these and many more. Visualization is an empowering technology. Its value lies not in the visualization itself, but in how it allows you to understand and explore data. For big data, this means that visualization needs to show not the raw data, but analytics and models of that data. We don't want to show 1,000,000,000 points in a scatter plot, we want to analyze that data and show the results of those analytics. Here's an example. This is an example of a multi-scale scatter plot, a display where we have taken the bulk of the data and aggregated it, displaying it as circles on this plot. Millions of cases of data have been aggregated in this chart. The darker circles represent the highest density of points, the lighter circles represent fewer points, but still a considerable quantity. Some predictive analytic techniques have isolated some important scenarios from this simulation data. These are shown on the outside as stars, representing data which is not aggregated but are individual scenarios. Data points belonging to the same simulation are shown in the same color. This means we can look at the chart and see immediately those areas relating to unusual activity or unusual scenarios in our dataset. We would probably complement this plot by a brushing or a linking metaphor, so as we brush over one of these interesting points, we would see much more details on this information pop up in another view at a much lower resolution scale. This example shows what is needed from a modern visualization engine. Not the ability to show 1,000,000 rows of data, although speed and capacity are always important, but the flexibility to take the data in multiple forms and at multiple scales and combine them into an informative visualization that allows us to explore data, highlight important features, and use the knowledge gained to make decisions with confidence. In a nutshell, to handle big data, the number one requirement is flexibility. Power comes by being able to handle any form of data at any scale, and by the ability to integrate different visual metaphors and interactions to give big data analysts the ability to view anything.